Okay, so in this video, we'll be looking a little bit closer at tangents and circles. So when we're looking here, right, we'll learn that if a line is tangent to a circle, then the line is perpendicular to the radius drawn to the point of tangency. So this line here is tangent here at this point right here, which means that this radius must be perpendicular to that tangent. Now you can imagine if that radius is extended to become a diameter, then this inscribed angle would intercept that 180-degree arc, which makes this angle 90 degrees. Therefore, giving you proof that if a line is tangent to a circle, then the radius to the point of tangency must be perpendicular, because they'll have to be half of 180, which is 90 degrees. Now this can create some right triangles, right? So you're going to be thinking a squared plus b squared equals c squared, and we'll look at that in a little bit. So some different ways this can look is if I tell you that these two lines are tangent to the circle, then you know that these are right angles. They have to be perpendicular, which means this quadrilateral, right? It's a quadrilateral. So quadrilaterals, we know, equal 360 degrees. So if these are both 90, that's 180. So then this angle here we'll say is 120. If that's x, then it has to be 120 plus x equals 180. Because these two opposite angles have to give us the other 180 to make 360. So x has to equal 60 degrees. So that's one type of problem that you'll be given. Note that this picture here, since those tangents are congruent, and since these radii are congruent to each other, that is a kite, right? That is a kite. So we know that if I was to draw in these diagonals, that would have to be a right angle, and these angles would have to be bisected, and then we'd have little mini right triangles. So another thing you might see is, again, this diameter creates a perpendicular angle. So let's say this was 47 degrees, and I ask you for that. Well, in this case, we have a right triangle. Right triangles are worth 180 degrees. So that means that 47 plus x has to equal 90. So I've already got a 90 here, so I need 90 more. So x has to be worth 43. And those are the types of problems that you'll have to deal with when you're working with angles and tangents. Types of segment problems is that you can tell me whether or not, if I tell you that this is tangent, if I tell you that that's a tangent line, then you know this is a right triangle. So if I call this 5, and I say this is 12, and I ask you for this little piece on the outside. Well, what you can do is you can consider this whole thing as C, and you can think to yourself, well, it's a right triangle, so 5 squared plus 12 squared equals C squared. And 5 squared plus 12 squared gives me 169, so C equals 13. Now that I know C is 13, I also know that if this radius is 5, then this radius is 5. So that means 5 plus x has to equal 13. So x has to equal 8. And those are the types of problems that you'll be seeing in the classwork during next class. If I tell you that that is perpendicular, then you can tell me that it's a right triangle. You can find the missing piece by doing the Pythagorean theorem. Sometimes you have to think your way through it a little bit, but it's going to involve the Pythagorean theorem. Now, what if I say, well, this is 6, 8, and this is 11. And I ask, is this line tangent? And the only way to know is to find out, does this make a right triangle? If it makes a right triangle, then indeed it is a tangent line. If it's not a right triangle, then it's not a tangent line. So this is 36, 64, 121. So 100 equals 121. They're not congruent, so it is not tangent. It has to be a right triangle to be tangent. And if we remember, this hypotenuse is too large, therefore it's an obtuse triangle, and obtuse triangles do not make tangent lines. Okay, the last thing we talked about here, which was also very similar to what we did last class, is that two tangent lines intersect, and the point of intersection is equidistant from each point of tangency, and the segments are congruent. And we've seen this before, right? If these are both tangent, then they have to be congruent to each other. And now we kind of understand why, because those are right angles, so that means that A, B, C, this would also be A, and that's C, so this would also have to be B. So A squared plus B squared has to equal C squared, and A squared plus B squared has to equal C squared. So again, we get right triangles is another way to prove that two tangent lines will be congruent to each other. So what would that look like? If I give you something like 5x plus 3, and I give you 2x plus 12, then you'll be able to tell me that, well, 5x plus 3 equals 2x plus 12, which you should remember from last class. 3x equals 9, so x equals 3. You're doing problems like that. Now the problems here we'll see is if I give you this and I say, well, this side is 6, and this whole thing is 10, and this piece here is 2. Find the perimeter. Well, what I know is that if this is 6, this also has to be 6. If the whole thing is 10, then this piece has to be 4, which makes this piece 4, and which makes this piece 2. So that gives me this side here has to be 8, this side has to be 6. So 10 plus 8 plus 6 gives me a perimeter of 24. So you'll have problems like that. All right, and again, it's just the same idea that tangents to a circle are congruent to each other if they intersect. All right, so that's the notes. We'll work on these types of problems. We'll also look at equations of a circle in class next time.